Hello, my name is NanthaKumara. The aim of investigation is to evaluate the trade-off between the cloud data persistent versus persistent using Firestore and local persistent using the room in a real-time event management content. Especially, I explored how cloud synchronization impact regarding battery and data usage and how is it satisfied through atomic transaction. My objective was to determine if the latency cost of the cloud is justified by the benefit of real-time multi-user synchronization in a real community-driven app. Having an accurate seed count is more critical than a raw speed, and this experiment proves why. Part 2, methodology. So, to conduct this experiment, I utilized the Android Studio Profiler to perform the live telemetry. I measured the hardware cost of the seat booking transaction by monitoring network payloads and CPU stabilization times. I compared my current cloud implementation against a local-only write simulation. To ensure a fair test, both variants utilize my MVVM architecture and Kotlin coroutines. This isolates the heavy input and output task from the main UI thread, ensuring a non-booking 60 FPS experience for the user for the user for the user. Notice the network spikes in the profiler represent the Notice the network spikes in the profiler. This represents the handshake and the data transfer is required to synchronize the event status with the Firebase servers. Part 3, results and data analytics. As you can see, the result revealed a significant performance gap. Local storage is roughly 85% faster and save battery by bypassing the mobile modem entirely. My data showed that cloud Firebase has a latency of roughly 340 milliseconds per write under standard network condition. However, speed isn't everything. My stress test showed that local storage failed to meet the single source of truth requirements. Cloud Firestore provides atomic transaction which is successfully prevented race condition. During my test, I simulated two users booking the final seat simultaneously. Firestore's transaction logic locked the document, ensuring that only one booking success, whereas a local database would have allowed a double booking error across different devices. And then this visual demonstrates the 85 faster claim. Shows the tutor you have qualified this is the faster than 15 milliseconds. And then this is the room SQLite local and then cloud, Firestore cloud, and then the findings. Part 4, discussion and recommendation. In conclusion, my investigation provides that for a community-driven app, the data integrity is more important than a 50 millisecond per speed of a local database, while cloud persistence has a higher hardware cost on the modern and battery. It is necessarily trade-off to ensure a fair and synchronized booking system. Based on these results, I recommend using a hybrid approach for future version, catching data locally for speed, but required a cloud transaction for any atomic action like speed booking. This investigation directly enhanced my final product by validating my use of real-time snapshot listeners, which you can see here keep all the user in sync instantly. Thank you.